Here's some homework help for lesson 5.4. This is page 341, and I've picked 3 problems to do. This first one is out of that first block of problems where you're supposed to identify the domain and range of this square root function. So let's start with the domain. If you want to find the domain of these square root functions, remember we have to avoid a negative number, the square root of a negative number. So the way to do that is just to take the expression underneath the radical and set it up as an inequality that says this result has to be greater than or equal to 0, because in essence that is what must happen. Otherwise we're going to have the square root of something negative. So the way to avoid the square root of a negative number is we must choose for x all numbers that are greater than or equal to 2. So the result for the domain, we can express it like this, will be all x such that x is greater than or equal to 2. For the range, you can take your result that you got in solving this little inequality, the 2, plug it in for x in the original function, and if you do, I'll just show you the result. I'm just letting x become 2 from my domain and simplifying, and 4 times 0 is 0, minus 8 is negative 8. Alright, so this represents the bottom part of this function, because remember, if this a number is positive, then the graph of this is going to do something like this. In other words, this end point is going to be at the very bottom, and then we're just going to go up from there. So you can think of negative 8, which is the result of plugging in my value of 2. Negative 8 is the y-coordinate here, and we're just going to go up from there. So we can finalize this for the range. It will be all f of x such that f of x is greater than or equal to negative 8. Okay, so here's my domain answer, and hopefully you see how we got that. Using that number will help you get the range, and then also understanding with this being positive, the graph is going to go up. So with a being positive, you're always going to have greater than equal to. If a is negative, that means your graph is going to do something like this. So this end point represents the highest point, and so you're going to have less than or equal to whatever that y value happens to be. So here's your range answer. Okay, and then I wanted to do a couple of graphs for you. Let's do number 20. And this one's a little different. It's not really the translation of a parent function like we talked about in class, so I just wanted to go ahead and do this one with you. We're just going to make a table. In class, the true parent function has just a regular 1 here as a coefficient. But these are easy enough. Instead of graphing it as a translation of the parent, y equals the square root of x, we're just going to do some inputs and outputs. So if I let x be 0, I'm going to get an output, or a y of 0. You can do just about anything you want, but if I let x be positive 1, then I'm going to grab my calculator and I'm going to do the square root of 5 times 1, which is 5. And just find out what that decimal is. The square root of 5 is 2.24, but this is like multiplying by negative 1, so that changes it to negative 2.24. Okay, so 1 for x, and then negative 2, and then just a little bit more on the y. And let's just do another one. An easy point, maybe you've already discovered this, would be 5. Because that would give me the square root of 25, which is 5, but this makes it negative 5. So for f of 5, we get negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's sufficient to go ahead and draw this graph. So it's going to look like that. And now we have to state the domain and range. So the domain will be all x such that x is greater than or equal to 0. Okay, and the range will be all f of x such that f of x is less than or equal to 0, because that end point represents the highest point on the graph, and we're going to go down from there. Okay, so that's your final answer for number 20. And let's take a look at number 26. Now this is the translation of a parent, much like we talked about in class today. X has a coefficient of 1, so there's really three things I'm going to do to my parent points. Remember, we talked about the parent function. You can always use these points as a reference. And so basically we're going to do three things to these points. We're going to multiply the y coordinate only for each of these times 3/4. Then this says to take that result and move left 12. And this tells us then to move up 3. So the horizontal move is left 12. The vertical move is up 3. And I know this is kind of big for the graph paper that you've got, but if you need to, you can make a couple of marks on the end, or you can change your x-axis into 2's if you want to do that. That's fine. So let's just start by multiplying the y coordinate of this origin point by 3/4. Well, 3/4 times 0 is still 0. And now I'll do the shift of left 12, 2, 4, 6, 8, 10, 12, and then up 3. And that origin point is now this left point over here in red. All right, let's work on the next one. When I multiply the y coordinate here by 3/4, I get 3/4. So 1 3/4. And now I'm going to do the left 12. And up 3. And that puts me here. All right, let's work on the next one. This is 4 2. But when I multiply 2 times 3/4, I get 6/4, which is another way of saying 3/2 or 1 1/2. All right, so here I am at 1 1/2, and now I'm going to go left 12 and up 3. Takes care of that one. And then finally, I'm here at 9 3. But when I multiply 3 times 3/4, I get 9/4, which is another way of saying 2 1/4. Okay, so instead of being up here at 3, remember this is compression, I'm going to go down to 2 1/4. Then, so here I am at 2 1/4, and now I'll do the left 12 and up 3. And those red dots represent the graph of this function. Let me erase all this. We'll connect the dots. And now let's do domain and range, and we will be completed with this. So the domain will be all x such that x is greater than or equal to -12. The endpoint is -12 on the x. And the range will be all f of x such that f of x is greater than or equal to 3. Starts at 3, and it's going to gradually continue to go up for larger numbers of x. And so those are your answers to those 3 homework problems. I hope this helps you with the rest of the problems. If you have any questions, let me know.